Hello class, in this video we'll be finding the equation of a straight line. The learning intention of this video is for us to learn how to find out the gradient from two coordinates and to find out what is therefore the equation of a straight line using those two coordinates. The first thing that I want to do is quickly go over what is the general formula of a straight line. So the general formula of a straight line is given by the slope-intercept form, which is y is equal to mx plus c, where m represents the gradient of a straight line and c represents your y-intercept. In order for us to find out what is the equation of the straight line, we're going to follow these steps in the following order. The first step is to find out what is the gradient, and the gradient can be determined by using this formula that I'm showing over here. The second step is to therefore find out what is our y-intercept. And this is done by substituting your gradient as well as a coordinate into the general formula and solving for c. And lastly, plugging in all our values into the general form so that we've got the equation. So let's firstly go over how do we actually calculate the gradient of a straight line. In our previous video, I've talked about the gradient being a way for us to describe how steep the straight line is, either increasing or decreasing for every unit that you move to the right. In other words, the gradient is determined by finding out how much you're rising / falling and dividing it by how many units you're actually running across. So if you look at an example over here, if you take these two coordinates of the straight line, you can see that the run in this case, the horizontal is 14 and the rise is 7. So if you were to find out what was the gradient for this particular example, it would be therefore 7 divided by 14, which is the same thing as half in this example here. A mathematical way for us to find out what is the gradient is by using this particular formula here. So that's m is equal to y2 minus y1 over x2 minus x1. Now what x1, x2, y1, y2, these are essentially the values of two coordinates. So x1, y1 represents the first coordinate, whereas x2, y2 represents the second coordinate. So what I could do is, using these two coordinates over here, I'm going to label them as x1, y1, x2, y2 like so. And from this, you could therefore plug it in to the formula and therefore solve for the gradient. So I'm going to go through a couple of examples. So the very first step is, let's quickly identify two easy coordinates that lie on a straight line. Now, oftentimes you will be given the coordinates, but sometimes when you're given a graph, they don't actually label the coordinates. So you have to actually manually choose coordinates that are easy for you to work with. So in this case, I don't have to worry about that because these coordinates are already given to me. The second step is for us to label the coordinates as x1, y1, x2, y2. So if I do it, it's going to be something like this. And the last step is to therefore substitute these values into the formula to calculate my gradient. So in this example, y2 is 6 and y1 is 0. So therefore I'm going to go write 6 minus 0, and then x2 in this case is 0. x1 is negative 4, so it's going to be 0 minus negative 4. Please be mindful of this because two negatives do make a positive, so your gradient in this case is going to be 6 over 4, which can be simplified to 3 over 2, which is the same thing as 1.5 in this case. Let's go through another example. So in this example over here, notice how they don't give you those labeled coordinates. So what we'll do is we'll have to find two coordinates that lie on the line that are very easy for us to work with. So the very first one in this case over here is I could be using these coordinates which I've identified. I could use the y-intercept and this coordinate over here. So once I've identified two coordinates, I'm going to label them as x1, y1, x2, y2. And therefore substitute it in. So y2 in this case is 1. So I'm going to go 1 minus 3 divided by 1 minus 0. Just quickly simplify that. So that becomes negative 2 divided by 1. And that is therefore going to be equal to negative 2. Let's look at one more example. So notice that this example is a bit different. Instead of actually giving you the graph, they've actually given you what those two coordinates are. So from that, we could immediately go on to the second step. So therefore, label these coordinates as x1, y1, x2, y2, and substitute those the values in. So it'll become negative 4 minus 8 divided by 10 minus negative 4. Remember, two negatives make a positive, so it's going to become negative 12 divided by positive 14, which can be further simplified as negative 6 over 7. We've just gone through 3 examples of how to calculate the gradient from 2 coordinates. The next thing that I'm going to show you is how we can actually roughly determine what the gradient is going to be based on the graph alone. So the gradient of a straight line could either be a positive value, a negative value, it could equal to 0, or it could also be considered to be undefined, meaning it does not exist whatsoever. So we know that any graph where if you start from left to right and it increases, the gradient is going to be given a positive value. Without doing any working out, I know it's going to have a positive value. In contrast, if the graph actually decreases from left to right, then it's therefore going to have a negative gradient, okay? The next gradient is where you have a flat horizontal line, so the gradient is going to be equal to 0. The reason why it's going to be equal to 0 is because that in this example over here, you're not actually rising, you're not actually increasing vertically at all, and because of that, any value, 0 divided by any value is therefore going to be equal to 0. So that's why the gradient is equal to 0 in this case. And for the very last example, as you can see over here, whenever you got a vertical line, because in this example, you're not actually running at all, any value divided by 0 is going to give you an undefined answer on your calculator. So that's the reason why no gradient exists whatsoever. It's really important that you understand this information because that when you actually calculate your gradient, and let's say that you've got a gradient value that was, let's say, equal to +5, but on the graph, it looks like it's going from this way, that actually tells you that you've actually made a mistake somewhere in your calculations for your gradient. Have a go with answering this question over here. It reads, identify the line below that has a gradient of +2. Now, in order to answer this question, I know that we could actually do this by using the formula to calculate the gradient, but for this particular question, you don't actually need to do it for a multiple choice question. Notice that your gradient value is a positive value, and we know that all positive graphs have or go in this particular direction. So as a result, I could automatically say that C is going to be the correct answer because for A, that's a negative graph. And for this example over here, that's where you've got an undefined gradient. So I could immediately say that C is going to be the answer without showing any working out whatsoever. Have a go with answering the next question. It reads, identify the line below that has a gradient of -0.5. Similarly, I'm also going to quickly try to cancel out options that are not viable whatsoever. So because the gradient is a negative value, I know that it has to decrease from moving from left to right. So as a result of that, I could therefore eliminate option C because option C, you've got a positive gradient. What I'm going to do next is, I know that I've got 2 graphs that has a negative gradient, but I need to find out which one's -0.5. So let's actually work out what the gradient is going to be. So I've chosen 2 easy coordinates from both sets of graphs, and I'm going to now calculate it. So if I've done the calculations, as you can see, you can easily see that option A is going to be the correct answer. After these 3 examples, you should now have a solid understanding of how to find out the gradient. Let's now look at the second step, which is learning how to find out the Y-intercept. In order for us to find out the Y-intercept, we're going to follow these 3 steps over here. So the very first step reads, substitute the gradient into y equals mx plus c. Notice that I'm using the exact same example from beforehand, and previously we've calculated that your gradient was equal to -2. So let's substitute -2 into this form where m is going to be. So if you do that, it's going to be y is equal to -2x plus c. I'm now going to complete step 2 by substituting one of these 2 coordinates into the general equation. It doesn't matter which coordinate you use because you'll eventually arrive to the exact same answer. In this example, I'm going to substitute the coordinate 1, 1, and I want you to recall that that's your x value, that's your y value. So wherever I see x, I'm going to substitute that with the number 1, and wherever I see y, I'm also going to replace that with the number 1. So this is what my equation now looks like. I'm now going to simplify this. So -2 times 1 is going to be equal to -2. I want to undo the -2 to solve for c. So we'll add both sides by +2. And as a result, c is going to be equal to 3. So that's the value of my y-intercept. So now we've actually completed the second step. So therefore, in order to find out the straight line, in order to find out the general equation of the straight line, all you're doing now is substituting the answers from step 1 and step 2 into y equals mx plus c. So in this case over here, because I found that c is equal to 3, I'm going to substitute that back into this equation. So your answer is going to be equal to y is equal to negative 2x plus 3. What I want to go through next is talking about some of the common mistakes that I see students make when they're trying to find out the equation of a straight line. The first mistake is using the incorrect gradient formula. Now, we know that in order to calculate the gradient, that's found out by going y2 minus y1 divided by x2 minus x1. However, I actually see some students use a different formula, which is this formula over here, and that's where they've actually just flipped the numerator with the denominator. So if you use this method over here, you're going to get the wrong gradient and therefore the wrong y-intercept and therefore the wrong equation, okay? The second mistake that I often see is that students are using inaccurate coordinates when they're trying to find out the gradient and therefore the y-intercept. So what I mean by this is some students are often would round up or round down these coordinates to a nice whole number answer. So remember that I said at the start of the video, you want to try to identify two easy coordinates that lie exactly on a straight line. I won't bother using these two coordinates because I don't know exactly what these values are. It could be 1.1, 1.2, 1.3 for that y value over here. So I wouldn't choose these two coordinates. Instead, I choose this coordinate over here as well as this coordinate because I know that these values are essentially on the straight line and they'll give me a nice whole number answer. Let's finally go through one more example to show you the full process of how you could actually find out the equation of a straight line. So let's identify two easy coordinates which are given to us already. So step 1's done. Step 2 is to label them as x1, y1, x2, y2 like so. I'm now going to solve for my gradients by substituting the values in. So therefore in this case I'm going to go now x2 minus x1. So I'm going to go 3 minus negative 2. 3 minus negative 2 becomes positive 5. Negative 10 divided by 5 is going to be equal to negative 2. So my gradient is going to be negative 2. I'm now going to substitute my gradient into the y is equal to mx plus c. So I've done steps 4 already. I'm now going to substitute one of the coordinates into the equation as well. So I'm going to substitute this coordinate over here into the general equation. Negative 2 times negative 2 is equal to positive 4. Solve for c, so let's get rid of the 4 by subtracting both sides by 4. So therefore c is going to be equal to positive 1. So that's my y-intercept. And finally, as my last step, I'm going to substitute all the values into the general form. Hence, my equation is going to be y is equal to negative 2x plus 1. I want you to now have a go, so give yourself 2 minutes and answer this question. So for this question over here, I'm going to label my coordinates as x1, y1, x2, y2, and then use this to find out my gradient. So if you found out your gradient is going to be equal to positive 4. Substitute one of the coordinates into the equation. So I'm going to substitute this coordinate over here because it's got a lower numbers and it's going to be easier in this case. So I'll substitute 3, 6. I'm going to multiply 4 with 3, so that becomes 12. Undo the positive 12 by subtracting 12 from both sides of the equation. So therefore, c is going to be equal to negative 6. And therefore, my answer is going to become y is equal to 4x minus 6. At this stage, you should be able to now find out what is the equation of a straight line. These are the typical questions that you will encounter, but remember, even though these questions may appear slightly differently, the same process still applies. You just need to find two easy coordinates that lie on the straight line, and then you find out the gradient and the y-intercept so you can find out the equation. Please answer these questions from exercise 1G to further get more practice. Thank you for watching today's video. Hopefully you're able to meet the success criteria. I'll see you guys again in the next video. Bye.